Atomic radius, periodic trends of atomic radius.
Starting the lecture, click on the subscribe button and get access to our 100 of unique and simple lectures for free.
Firstly, now what is atomic radius? Well, the distance between nucleus and outermost electron is called atomic radius. For example, consider a neutral hydrogen atom. We know that there is only one shell in a single hydrogen atom and one electron in the shell. This shell of the hydrogen atom is called valence shell or outermost shell, and this electron is called valence electron or outermost electron. Now listen carefully. The distance between the nucleus of hydrogen and outermost electron is called the atomic radius or radius of the hydrogen. Secondly, consider a neutral sodium atom. We know that there are 3 shells in the sodium atom. The first shell of the sodium contains 2 electrons, the second shell of sodium contains 8 electrons, and the third shell of sodium contains only 1 electron. This electron of the sodium is called outermost electron. Now listen carefully. The distance between the nucleus of sodium and outermost electron is called atomic radius or radius of the sodium. Here, let me teach you a bonus MCQs. Atomic radius is measured in micrometer, nanometer or picometer. Well, the answer is picometer. Atomic radius is measured in picometer. Now let me teach you about the periodic trends of atomic radius. For instance, atomic radius across the period or atomic radius from left to right in the periodic table. For example, in the second period of periodic table, there are lithium, carbon, oxygen and fluorine. We know that the atomic number of lithium is 3, the atomic number of carbon is 6, the atomic number of oxygen is 8, and the atomic number of fluorine is 9. Also, we know that atomic number of a neutral atom indicates the total number of protons and electrons. So, in the lithium atom, there are 3 protons and 3 electrons. In carbon atom, there are 6 protons and 6 electrons. In oxygen atom, there are 8 protons and 8 electrons. In the fluorine atom, there are 9 protons and 9 electrons. Here, we can see that there are 2 shells in the lithium atom, there are 2 shells in the carbon atom, there are 2 shells in oxygen atom, and there are 2 shells in fluorine atom. Now listen carefully. As we go across the period, atomic number increases. Secondly, the number of shells remains constant. Here, let me ask you, in which atom there is highest attraction between protons and electrons? Well, the highest attraction between protons and electrons is in the fluorine atom, because there are 9 protons and 9 electrons in it. Due to this highest attraction, the electrons come towards the nucleus and the size of fluorine atom decreases. On the other side, there is lowest attraction between protons and electrons in the lithium atom because there are only 3 protons and 3 electrons present in it. Due to this lowest attraction, electrons move away from the nucleus and the size of lithium atom increases. To conclude this, we say that atomic radii decreases across the period or from left to right in the periodic table. Here, let me also teach you exam-based conceptual question. Why the atomic radius of fluorine is smaller than carbon or lithium? I hope that you know the answer. The atomic radius of fluorine is smaller than carbon or lithium because the atomic number of atoms increases across the period. Secondly, the number of shells remains constant across the period. Thus note it down that atomic radius decreases across the period because the atomic number increases across the period and the number of shells remains constant. Now let me teach you atomic radius down the group or atomic radius from top to the bottom. Well, consider the elements of first group of periodic table like hydrogen, lithium and sodium. We know that the atomic number of hydrogen is 1, the atomic number of lithium is 3 and the atomic number of sodium is 11. There is only one proton and one electron in hydrogen atom. There are 3 protons, 3 electrons in lithium atom and there are 11 protons and 11 electrons in sodium atom. There is one shell in hydrogen atom, there are 2 shells in lithium atom and there are 3 shells in sodium atom. Now listen carefully. Atomic number increases down the group. Secondly, number of shells also increases, due to which shielding effect also increases. Now what is shielding effect? Well, shielding effect means the inner repulsion in the shells between electrons. For example, the electrons of second shell shield or protect the electrons of the third shell from the attraction of protons or nuclear attraction, due to which electrons in the third shell experiences less nuclear force of attraction and move away. To conclude this, we say that atomic radius increases down the group or from top to bottom. Because atomic number increases and number of shells also increases, due to which shielding effect increases. Finally, let me teach you exam-based conceptual question. Why the atomic radius of sodium is larger than lithium or hydrogen? I hope that you know the answer. It is because down the group atomic number increases, number of shell increases and shielding effect also increases. Thus noted down that atomic radius increases down the group. To conclude my lecture, we learned that atomic radius is the distance between nucleus and outermost shell of an atom. Secondly, we learned that atomic radii decrease across the period. Although the atomic number increases, but the number of shells remains constant. Thirdly, we learned that atomic radii increase down the group. It is because atomic number increases, number of shells also increases, and shielding effect increases. I hope that you have learned all about atomic radius and trends of atomic radius in the periodic table.